Alright, so up to this point we have added our c, that constant of integration, and now we want to go back and see, can we find out what that exact value of c is? So we're going to solve what we call an initial value problem. So the only way that we can actually find out what c is if we know something a little bit more about the original function. So here we're told what the derivative of the original function is, and we're told something about the original function f. This little extra piece of information is going to help us to determine what is c. Alright, so first of all, we're given the derivative of, so we're given f prime. So the first thing we want to do is we want to integrate. We want to find out what is the original function, and we're going to integrate. We're going to integrate with respect to x. So I'm going to put my little dx there. So we are initially going to figure out what is that antiderivative with the plus c. Alright, so let's do that. We're going to do this just to the first term here. Let's see, we can set aside the constant and focus on the part that has the variable. So we're going to look at the first term. I'm going to do a little bit of a shortcut here. I'm not going to actually physically separate them this time, and I'm not going to actually pull out the 3. We're just going to kind of do a couple of steps all at the same time. So we have the 3, and we have the x squared. We're going to focus on the part that has the variable, so the x squared. We know we're going to add 1 to the power, so I get x cubed, and then we know we're going to divide by that new power. So for that first term, when we integrate it, we end up getting x cubed. Now, how can I test to make sure I did that correctly? Well, if you found the derivative of x cubed, wouldn't you get 3x squared? So then we know that we are doing it correctly. Alright, let's look at the next one. We have minus 6x. So I'm going to go ahead and just bring down the minus 6. And right now, the exponent on that variable is 1, so I'm going to add 1 to the power. So I'm going to get x squared. And then I'm going to divide by the new power, which is 2. Okay, and I'm going to simplify that, and we get negative 3x squared. Okay, and we can test that out. Once again, if I found the derivative of this function, then I would get back up to negative 6x. So if I found the derivative of that term, I would get right back to where I started. So we're going to put the plus c, because we don't know yet what that constant of the integration is. So I'm going to put f of x equals. So I want you to notice something before we move on. We started out with the derivative, and what we have now found is the antiderivative, and we find the antiderivative using integration. So this is the antiderivative. Notice that we still have that constant of integration there. We have not used this extra piece of information about the original function yet. Alright, so now let's find c. So the first thing you want to do is find your antiderivative. The second thing that we want to do is we want to find c. So what does this extra piece of information tell us? The extra piece of information says that if an x value of 2 goes into the function, then a y value of 4 should come out. That's the output. So here we have this c. We want to make sure that c helps to secure this output. So if x value of 2 goes in, a y value of 4 should come out. So let's put an x value of 2 into the function. So it's x cubed minus 3x squared and then plus c. So we're going to put the 2 in place of x throughout that function, throughout that antiderivative. We have the plus c. What do we know that this should be equal to? Well, we know that this should be equal to 4. So let's see what happens. We're going to simplify. 2 cubed is 8 minus 2 squared is 4, so it gives me actually officially minus 12 overall plus c, and we know that this is supposed to be equal to 4. So what does c have to be in order to guarantee an output or a result of 4? C has to be, well, let's solve for c. So we get 8 minus 12 is minus 4 plus c. We're going to add 4 to both sides, so we get that c equals 8. So if c equals 8, then the output will be 4. So we're going to plug in, right here, we're going to plug in an x value of 2 into the function, and then we solve for c. Alright, so what is our official original function then? So our official original function would be f of x equals x cubed minus 3x squared plus 8. So this right here is our final answer. This is the original function including the value of c. that we are looking for. Okay, so this is called an initial value problem because I give you extra information about the original function so that you can plug in that x value into the antiderivative, and then you can solve for what c would have to be in order to obtain that output value for y. Alright, so our last example here is a little bit more of a word problem. Also, though, this is just a form of the initial value problem that we talked about. So I'm going to go ahead and just write that down here. Okay, so this is basically just another form of that initial value problem. So we're told that Canon Precision Instruments makes an automatic electronic flash with a particular type of circuitry. The estimated marginal profit, remember marginal profit meant a derivative of the original profit function. So it says the estimated marginal profit associated with producing and selling these electronic flashes is given here. So here we have the derivative of the profit function. So p prime of x equals, and we have our derivative. This gives dollars per unit per month when the production level is x units per month. So a little bit of information about the derivative there. Canon's fixed cost for producing and selling these electronic flashes is $16,000 per month. Okay, let's stop for a second and break down what that means. Fixed cost. Remember that a fixed cost is not dependent upon how many objects that you sell, so how many units you sell. A fixed cost is something that you're going to pay to produce and sell regardless of how many you sell. So even if you sell nothing, so here's the idea. I'm going to say P. Now notice this is not P prime, this is just P. How much profit would I make if I sold 0 units? So let's say that I sell nothing. Well, I still am losing $16,000. So that means that I would end up still paying out $16,000 if I sell nothing. So the fixed cost, $16,000 per month. If I sell no units at all, my profit, then I would be losing that negative $16,000. So assume that you produce nothing and you sell nothing. That's kind of the idea there. Okay. So you produce 0 units and you sell 0 units. Okay, so if you do nothing, you're still paying that $16,000, so you're losing that money. So you can imagine that if you rented out, let's say you rented out a big space to manufacture your product, and you didn't buy any supplies, you didn't do anything, you would still end up paying $16,000, let's say, in rent, regardless of what you did in the building. So that's kind of the idea there. Okay, and this is something we know about the original function, in other words. This is something we know about the profit. So this is part of that initial value function. We know something about if I plug in this x value, we know what the y value would be that came out. So our question is, at what level of production does Canon realize a maximum profit, and what is the maximum profit? Okay, so that's what we want to know. Now, the idea of talking about a maximum profit actually comes from the derivative, right? Remember when we were doing max values and minimum values in section 4.1? This actually comes from the derivative of the function. So let's work with what we know. Okay, so our derivative we're going to answer this question about what level of production will they realize the maximum profit. And of course this comes from setting the first derivative equal to 0. So I'm going to set the first derivative equal to 0, and we're going to solve for the number of units that it would take to maximize the profit. So I'm going to subtract 20 from both sides. Oops, too many zeros. And I have an x there, sorry. So negative 0.004x equals negative 20, and then we're going to divide by negative 0.004. Keep wanting to throw in more zeros. Alright. So we get x is equal to, so negative 20 divided by negative 0.004. So we should obtain a positive value, and we get positive 5,000 units. So this is the level of production that maximizes the profit. Okay, so that first question is a question that we would have done basically back in section 4.1. We want to know how many units would actually maximize the profit. Now, the second question says, what is the maximum profit? So we're looking for what is that relative max or that relative min or that absolute max and the absolute min. So we want to keep something in mind. In order to obtain the maximum profit, if you think back to section 4.1 or also back to section 4.4, if I was looking for what the actual maximum value is, then I have to have the original function. So I need to plug in back into the original function in order to find out what is that maximum profit. So how do I find the original function? Well, I have the derivative. So what I need to do then, in order to get the original function, is I need to find the antiderivative. So I have the derivative, and I want to find the antiderivative of that derivative. So we're going to integrate. So I'm going to integrate p prime of x with respect to x, and that's going to give me back to the original profit function. So let's integrate. We have negative 0.004x plus 20. So we're going to integrate that with respect to x. Alright, so remember that negative 0.004, if I want to, I can bring that out. Oops, bring that out. That's a constant multiple. So I can make that look a little easier. And then I can say plus, we can integrate the second term, 20, by itself. So if you wish to, you can separate them out in two separate integration problems. And of course, my exponent right now is 1. I'm going to add 1 to that. Then I'm going to divide by the new exponent. Then I'm going to be careful to make sure that I bring down that constant multiple that I brought outside of that integration. Plus, now the second term, that's just a constant. So I'm going to multiply that by x. So we have 20x. And then, of course, we don't know what the constant of integration is yet, so we're going to just put the plus c for now, and we'll see what happens. Alright, so this is our profit function. Alright, let's simplify it a little bit. So our profit function, 2 goes into negative 0.004. I don't know how many times. Let's simplify that. We get negative 0.002x squared plus 20 plus the constant, plus 20x plus the constant that we don't know yet. Okay, so this is our antiderivative. Now, I would like to find the entire original function, including what is the value of c. So my next question is, what is the value of c? So here's our antiderivative. We want to find c. How do we find c? Well, we have to know something about this original function. Is there any extra piece of information that we know about the original profit function? Well, yes. We said the fixed cost. If we produce and sell 0 units, then we know we still have to pay out that rent or that fixed cost of negative $16,000. So we're still losing money. So we actually know something about the original function. We know that if a 0 goes into the function, then we should get out negative 16,000. So we're going to take our original function and we're going to plug in a value of 0. Just like we did with the last problem, we're going to put in an x value of 0. This is actually really convenient that we're plugging in 0. We don't know c yet, but we know that it's supposed to be equal to an output value of $16,000. Really convenient that we're plugging in 0, because 0 squared is 0. And then 0 times anything else. So this whole entire term just becomes 0. 20 times 0, 0 plus c. So we get c equals negative 16,000. So let's go back and write our original function now. So now that we know what c is, the original profit function we know completely. P of x equals negative 0.002x squared plus 20x minus 16,000. So that's really important. We know the original function now, and we know the c value. We know everything about the original function. Now remember, how can you test this out? Well, we can test it out by taking the derivative of it and seeing that we get back the original derivative, okay, which is right here. And you should get that as the original derivative. Remember, the constant, we take the derivative of that, you get 0, so we should end up right back with that original derivative. So here's the original function, the p, profit function. Now remember, our last question was, if we produce 5,000 units, so we said, at what level of production does Canon recognize a maximum profit? We said if they produce 5,000 units, so if they produce and sell 5,000 units, they will obtain their maximum profit. We want to know, well, how much money would that be then? If we produce 5,000 units, how much profit are we actually bringing in? So that means that we're going to go back to the original function that we just formed, and we're going to put in 5,000 units. So we're going to put 5,000 in place of x. So we're actually going to use this profit function that we just formed to answer the question about how much money that we will be making if 5,000 units are produced. Okay, and you're just going to throw that right into your calculator as is. Should be a pretty easy calculation there, and you should get $34,000. So this is the maximum profit when 5,000 units are produced and sold. So keep in mind that this is just an initial value problem. We know something about the original function. We're given the derivative of the original function, so we can find the original function by integrating and then determining the value of c.